Alright guys, just finishing up our day 2 lesson of graphing using Ratey. So we just had number 6 left over, so let's finish this one up. Alright, so nothing to cross out here, so we're not going to get any holes. There's just a lot of stuff going on, so we're going to have a lot of different things to graph. Alright, so we're actually going to have two different roots because we have two different factors up here. So we're going to have x equals 2, so that gives me 2 comma 0 as a root. And then this one would be x equals negative 4. So that gives me negative 4 comma 0 as another root. Alright, for asymptotes, we actually have 3 asymptotes. So you can't forget about that x in front. That one counts. X equals 0. Then the x plus 1 will give us x equals negative 1. And then the x minus 5 will give us x equals 5. Togetherness. Yes, we do have togetherness because we have a perfect square in the denominator. The x plus 1 is being squared, so it's at x equals negative 1. Alright, but you'll notice that the other two asymptotes do not have togetherness. So only one asymptote with togetherness on this one. Alright, end behavior. Is it top heavy, bottom heavy, or balanced? On the top we have an x squared, x times x. On the bottom, we have an x squared times an x times another x, so an x to the 4th power on the bottom. So 4 is bigger than 2, making this bottom heavy, which means it's automatically y equals 0. Alright, and lastly, our y-intercept. Y equals 0 minus 2 times 0 plus 4 over 0 times 0 plus 1 squared times 0 minus 5. Alright, so this is negative 2 times 4 is negative 8, and this is 0 times, and it doesn't really matter what the rest of this is. If we're multiplying by 0, we're going to get 0. And we're not allowed to get something over 0, so that means there is actually no y-intercept. Interesting, that doesn't happen very much, and we could have actually predicted this because x equals 0, the y-axis is one of our asymptotes. So our graph's not allowed to touch the y-axis because it's an asymptote, so hence, no y-intercept. Alright, let's graph what we have here. And we're going to have to get a little more creative on this one to figure out our entire graph, but we can start with what we know. 2, 0, negative 4, 0. X equals 0, as discussed, is the y-axis. X equals negative 1, right next to that. And x equals 5. Alright, togetherness at x equals negative 1, so I'll put a t on that one. And then y equals 0. So we're actually going to end up going through this horizontal asymptote 2 different times, because we have 2 different roots on top of that asymptote. Alright, so the problem we have here and the way we have to get creative is that normally the y-intercept is the point that tells us like this one has to be here, and then we're able to figure out all the rest of them from the togetherness. But if we don't have a y-intercept, there's no way to know, like should it be on the top or the bottom? I don't know. So if you don't have a y-intercept, you need to pick another point. So I usually go with just 1. So I'm going to plug in 1 for my x values up here. So y equals 1 minus 2 times 1 plus 4 over 1 times 1 plus 1 squared times 1 minus 5. Alright, so that's negative 1 times 5 is negative 5. And then this is 2 squared is 4 times negative 4 is negative 16. So that's positive 5 over 16. So at x equals 1, I get 5 over 16, which is pretty close to a third, so just a little above there. Alright, and that's enough to help me graph this entire thing. Alright, so what that tells me is that this curve has to go like this, and it's going to approach the asymptote on the y-axis. This is one of those ones that's going to pass through, so it's not going to turn back around, it's going to go through, and the only option is for it to go and follow that one down like that. Alright, there's no togetherness on the right side, so I should not go on the bottom, I need to go on the top to avoid being right next to the one in the middle. There's no togetherness at 0, so I should not go on the top here, I should go on the bottom. And so this one is going to go up, and then the asymptote pushes it right back down. So a little skinny parabola looking thing there. All right, there is togetherness on this last one. So this last one needs to be right next to this little skinny one in the middle. And then we're going to hit that root right there. And so we're going to do that little bubble up thing and then come right back down and follow the asymptote on the top side. All right, that's about as tough as it gets on these. So if you can get that one down, if you followed that pretty well, then you should have pretty good success on graphing these going forward. All right, so hope you enjoyed. Hope you join us on our Google Hangouts or do the homework assignments, send me some questions, all right, whatever you need to do. And I will see you for the next one.